In 2012, a Toyota engineer confidently forecasted that the next era of cars would rely on batteries capable of lasting 1,200 km. More than 10 years later, that ambitious vision remains unrealized, and a staggering $58 billion has vanished into the seemingly endless abyss of solid-state battery research. Meanwhile, lithium-ion technology has silently taken over the electric vehicle market. So why do big automakers and flashy startups continue promoting the illusion of revolutionary advancements? The truth is that the real profit isn't in groundbreaking innovations, it's in selling the fantasy of disruption. Every year, without fail, headlines flood the news with extravagant claims. Breakthrough in solid-state batteries, game-changing battery tech arrives. Yet despite all these bold declarations, electric cars are still running on the same lithium-ion cells as before. Take Toyota as a prime example. While the company poured $2.5 billion into an uncertain battery revolution, its market share in the EV sector plummeted to a meager 0.3%. Rather than prioritizing practical solutions, Toyota became obsessed with a speculative future that never materialized. At least they built up an extensive collection of patents, though many of those patents now sit idle, offering solutions to issues that still lack real-world economic answers. On the other hand, BYD, a company largely unknown to many in the US, has already sold over 10 million electric vehicles powered solely by refined lithium-ion batteries. No futuristic gimmicks, no empty promises, just solid engineering and large-scale production. BYD grasped the core objective: make electric cars accessible and practical today instead of betting on unpredictable technologies that may never materialize. Consider QuantumScape, the company that became the poster child for solid-state battery hype. With $1.5 billion raised from investors like Bill Gates and Volkswagen, they promised a battery capable of charging in just 15 minutes and lasting indefinitely. Fast forward to 2025, and their stock has plummeted by 95%. But don't feel bad for the insiders. They pocketed $410 million in profits during the initial excitement cycle. The pattern repeats. Solid Power, another solid-state hopeful, partnered with BMW, causing its stock to soar by 236% in a single week. The mere association with a reputable automaker was enough to ignite investor enthusiasm. Today, the company trades at just $1.20, with its most notable achievement being a lab prototype the size of a postage stamp. Impressive for research purposes? Maybe. Relevant for mass production? Not at all. Meanwhile, CATL, China's battery giant, has been steadily refining lithium iron phosphate, LFP, battery technology. Once dismissed as an inferior alternative due to lower energy density, LFP batteries have now become essential for affordable EVs. By 2021, they held 32% of the global EV battery market. Rather than chasing speculative technologies, CATL focused on improving existing chemistry, optimizing manufacturing, and enhancing performance. The result? Their latest battery delivers an impressive 400 km of range with just 10 minutes of charging, a real-world game-changer that directly addresses the charging anxiety solid-state was supposed to solve. While American startups were busy filing patents, China was constructing factories. Today, there are 228 lithium-ion gigafactories worldwide. And how many mass production facilities exist for solid-state batteries? Just 3, with a combined output sufficient to power a mere 283 Teslas annually. The difference between hype and reality could not be clearer. Remember when Mercedes-Benz invested $1.2 billion into solid-state battery research? Their chief engineer later admitted in a private discussion that it was largely a strategic PR move, a calculated strategy to keep investors interested while the company continued refining conventional battery technology. The real progress? Mercedes slashed battery costs by 38% using existing tech, a tangible achievement that directly benefits consumers instead of fueling speculation. Follow the money. In 2023, venture capitalists injected $4.8 billion into solid-state startups, eager not to miss the next big thing. Meanwhile, CAT and emphasized $6.2 billion into expanding real battery production facilities. One group generates headlines, the other manufactures actual batteries. Which do you think powers the 2.4 million EVs sold last quarter? Solid-state battery technology faces three fundamental barriers: scalability, temperature sensitivity, and cost. These aren't minor issues, they are the core challenges that have hindered progress for decades. The so-called miracle ceramic electrolytes crack under normal driving conditions. The ultra-pure lithium metal anodes catch fire when exposed to air. These critical limitations are rarely mentioned in flashy investor presentations, where only the potential rewards are highlighted while real-world risks are conveniently ignored. Let's dive deeper. Mass production is one of the biggest challenges. While solid-state batteries look promising in a lab setting, producing them at scale demands entirely new equipment and processes, requiring massive capital investments and years of refinement. Then there's temperature sensitivity. Many solid electrolytes degrade quickly unless kept at precise temperatures, making battery management more complex and expensive. And let's not overlook cost. Solid-state battery materials are rare and difficult to source, driving up production expenses to levels that make them uncompetitive with lithium-ion alternatives. Another issue is dendrites, tiny, tree-like structures that can form within solid-state batteries, leading to short circuits and failures. While some claim solid electrolytes prevent dendrite formation, in reality they often emerge at the interface between the electrolyte and lithium metal anode, reducing efficiency and increasing safety risks. Solid-state batteries also face high resistance at their interfaces, slowing ion transport and lowering overall efficiency. Furthermore, they can be brittle and prone to cracking under mechanical stress, making them unreliable for the everyday demands of vehicle use. The geopolitical angle further complicates matters. China controls 80% of lithium refining, 68% of cobalt processing, and 95% of manganese supply chains. Solid-state technology was supposed to reduce dependence on these resources. Instead, it requires 5 times more lithium per cell than traditional batteries, deepening reliance on China instead of breaking it. Meanwhile, the so-called miracle solid electrolyte depends on raw materials sourced exclusively from Inner Mongolia. Wall Street understands this reality. BlackRock, one of the world's largest asset managers, has projected that solid-state batteries will remain commercially unviable until at least 2030. They aren't betting against the technology itself, just against the fantasy that it will be ready anytime soon. In contrast, CATL's new sodium-ion batteries have already broken the $60 per kilowatt-hour cost barrier, making EVs more affordable than gas-powered cars. Sodium-ion batteries, which use abundant and inexpensive materials, are emerging as a strong alternative to lithium-ion technology, especially for stationary energy storage. While startups were busy securing patents, GM's Ultium battery packs exceeded 700 km of range. While Toyota chased solid-state dreams, BYD's Blade battery survived being pierced by steel spikes without catching fire. Since 2015, $58 billion has been funneled into solid-state R&D, yet not a single production-ready battery has emerged. Meanwhile, lithium-ion battery costs have dropped by 89%, with range doubling and charging speeds improving significantly. Tesla, the company that transformed the EV industry, hasn't invested a dime in solid-state research. Instead, it is focused on refining existing technology and scaling production. The result? Tesla's 4,680 cells offer greater range than any solid-state prototype ever built. The real breakthroughs aren't happening in the realm of speculation. They're being forged in the relentless pursuit of large-scale production and continuous